From this, we can make our unknown variables ws and wl subjects of the formula. It depends on what you want to calculate first. So from equation 1, we can say that since we are saying ws plus wl equal to 1, so it simply means that ws is equal to 1 minus wl, right? Or vice versa. So if you take ws as the one you are substituting, you can substitute it in equation 2 by saying 1 minus wl cs plus wl cl is equal to co. So from this, you can have cs minus wl cs plus wlcl. Note that wlcs is not the same as wlcl. Meanwhile, you can collect like terms since both of them have wl. So you'll be left with cs minus wl into, so this will be left with cs, while here you have minus cl equal to c. And since we are looking for wl, you can take this to the right hand side, take this to the left hand side. So this will leave you with cs minus co is equal to wl into cs minus cl. To make it look more standard, you can take the one containing wl to the left hand side such that it will become wl is equal to, you can divide both sides by cs minus cl to isolate this, equal to cs minus co all over cs minus cl. So this is your equation for wl. You can name it as 3, right? If you're trying to calculate your ws, it's either you follow the same process by calculating your wl as wl equal to 1 minus ws and then resubstituting back, or you can use this as your wl and substituting it here, such that when you're calculating your ws, it will simply be 1 minus this. Alright, so you can say your ws is equal to 1 minus all the cs minus co all over cs minus cl. Now since this is a whole number, you can substitute it with cs minus cl over cs minus cl, as that will already cancel everything. So you have ws is equal to cs minus cl over cs minus cl. This makes both of them to have the same denominator, so you can fuse them together and simplify. When you fuse them together, your ws comes out to be, take, since they have common denominator, you have cs minus cl. So even if you divide this by this, it will still give you 1. So you take the numerator here, of course, you have cs minus cl, then minus cs, and this minus times this minus, since they are all in brackets, you can put the brackets so that you don't get confused. It will be minus cs plus co. So when you simplify this, cs will cancel minus cs, and you're left with co minus cl all over cs minus cl. Now for you to actually interpret this on your graph, you will notice that this formula is actually very, very simple, and this you'll understand. If you take a look at the graph, you'll notice that co is the parameter in the middle. So what did we say? We said ws is equal to co minus cl all over cs minus cl, right? And we said wl is equal to cs minus co all over cs minus cl. And don't get confused, actually here we used S to represent our alpha. So now take a look at this graph. The part that actually touched the L face is this green part, and it is represented by this length R, and this length R is actually equal to CO minus CL. And that is what we use to calculate WS, that's for the other one, right? And for the distance between our CO and our point that touches the solidus line, that's supposed to be this distance S. It's calculated by C alpha or CS minus C naught. So this is to imply that if you are calculating for this, if you're calculating for your percentage weight for the solid, you use this distance. That's distance between your reference point and the liquidus line. Understood? That's CO minus CL. And when you're calculating for the percentage weight of your liquid components, you take the distance between your reference point and the solidus line. So it's just interchanging the values. If you just understand that, you'll know that this whole formula is not really a big deal. And you'll understand this when we solve an example in the next video. Thanks for watching and stay tuned.